Now we'll see the molecular orbital of buta-1,3-diene. Okay, so in the case of buta-1,3-diene, we can consider buta-1,3-diene as 2 units of ethylene. Okay, earlier it was CH2 double bond CH2 and CH2. So we can consider butadiene as 2 units of ethylene. Okay, in that case it will be having there are two pi bonds. Okay, there are two pi bonds over here. So since it has got two pi bonds, it will be having 4 pi orbitals. Okay, okay, since you have two pi bonds, it will be having 4 pi electrons, or you can say that 4 pi orbitals. Okay, so 4 pi orbitals in the case of 1,3-butadiene can be said as pi 1, pi 2. Okay, okay, here we have pi 1, pi 2, then pi 3 star, pi 4 star. Okay, in the earlier case, what we said was ethylene. The case of ethylene, that is CH2 double bond CH2. So it was having just one pi electron pi bond, one pi bond. So it means it has got 2 pi electrons. Okay, or we can say that 2 pi orbitals. So 2 pi orbitals are there. Those 2 pi orbitals are represented as pi and pi star. Okay, when you have 2 pi orbitals, one will be bonding and the other one will be the anti-bonding. When you have even number of orbitals, we can say that it will be always having the equal number of bonding and anti-bonding orbitals. So in the case of 1,3-butadiene. 1,3-butadiene can be considered as 2 units of ethylene. 2 units of ethylene means it has got 2 pi bonds, so 4 pi electrons or 4 pi orbitals. So we can represent it as pi 1, pi 2. Okay, and then pi 3, pi 4, out of which pi 3 and pi 4 are found to be anti-bonding. So it can be represented as pi 1, pi 2, pi 3 star, pi 4 star. Star represents the anti-bonding orbitals. Now we will see this is how the bonding is, the orbitals are there. So this is carbon 1, 2, 3, 4, 4 carbons. Each of the carbon has got the p orbitals. The rest of the bonds we are not considering because we need only the pi bond formation. Okay, and the first case we can say that this always represents the energy, and the lowest one will be having the lowest energy, and this energy keeps on increasing. And when all are in the same plane, they will be having lower energy, and we can say, okay, all will be having same number of energy, and then we are numbering as pi 1, pi 2, pi 3 star, pi 4 star. So depending upon this number, we can say that there will be nodes that are present. Nodes. Okay, nodes means if it is pi 1 means n minus 1 is the number of nodes that will be present on a molecule. Here n represents this 1. Okay, 1, 2, 3 and all. So pi 1 means in the case of pi 1, n is equal to 1. So we have n minus 1, that is 0 node. 0 node means there won't be any charge separation there. So that is why all the p orbitals has got the positive sign to one direction and all the negative sign in one another direction. So we can say in this case n is equal to 0, there is no node. Now in this case it is pi 2. Pi 2 means n is equal to 2. 2 minus 1 is 1. So it means there will be one node that will be present. Okay, node means charge separation, and here it always follow the symmetric rule or the symmetric condition. So one node means there will be charge separation at this position. Okay, for this just one node, so symmetrically this will be cleaving the molecule or distributed in the molecule. So for that it will be having a node at here. So n is equal to 1. So for this to have a node at here, we should have the same sign. These two should have same sign, and these two will be having different sign, and these two will be having the same sign. What do you mean by node? When does a node form? Okay, in the earlier case we said that node formation when the overlap is taking place. Okay, the earlier case we showed like this. Okay, when there is overlapping taking place means there won't be node. When there is no overlapping taking place, okay, in this case there is plus minus minus plus. Okay, earlier we just discussed here. Okay, here there is no node formation because they are overlapping, so there is no node. Okay, here they are not overlapping, there is charge separation. Okay, since it has got the charge separation, we can say, okay, this is minus, this is plus, this is plus, this is minus. So plus and minus means opposite sign. So we can say that there is no overlapping taking place, so there is charge separation. So we can say that there is one node over here. Okay, so that is what you mean by the node formation. So when you have opposite sign here means there is one node, and these two should have same sign, minus and minus. So here there is no node, and plus and plus, so there is no node over here, because in this we are expecting only one node to form. Now we have pi 3 star. Pi 3 star means 3 is n. So n minus 1 is 2, 3 minus 1, that is 2 node should be there. 2 node means we can draw here and here, or here and here, but the only thing is that we always follow the symmetry rule. So we can say that there should be a node over here and there should be a node over here. So for that these two, for a node to be over here means if it is plus means it should be negative, and here no node, so negative means this should be negative. Here we need a node, so negative means it should be positive. So this is how we can say that n is equal to 2, that is you have 2 nodes over here. Okay, next case we have pi 4 star. In the case of pi 4 star, that is 3 is 4 minus 1, that is 3 nodes should be there. So 1, 2, 3. So plus minus plus minus. So you need not by heart these signs, you should just know how much nodes are present. So accordingly you can simply draw and look, and the only thing is that you have got to see the symmetry of the molecule. So this is how you can draw the molecular orbitals of 1,3-butadiene, and in the case of 1,3-butadiene they will be having 4 pi electrons. That is what we said. Okay, they will be having 4 pi electrons. So 4 pi electrons, the energy level can be shown as pi 1, pi 2, pi 3 star, pi 4 star. So one orbital can accommodate 2 electrons. So pi 1 will be having 2 electrons, pi 2 will be having 2 electrons. So in the ground state, the pi 2 will be acting as the HOMO, and pi 3 star will be acting as the LUMO. That is HOMO means the highest occupied molecular orbital, and LUMO means lowest unoccupied molecular orbital. And in the excited state, okay, in the excited state we can say one electron from the pi 2 will be jumping to pi 3 star. So pi 1 will be having 2 electrons, pi 2 will be having 1 electron, pi 3 star will be having 1 electron, and in this case we can say that HOMO is pi 3 star and LUMO is pi 4 star. And ground state means the thermal reactions are always considered to be in the ground state, whereas photochemical reactions will be having the excited, will be taking place in the excited state. Okay, so ground state means thermal reactions will be having ground state, and for photochemical reactions it will be having the excited state electronic configuration.